Hello and welcome to 6.4 Notes. All right, let's start off with an activity, and the question we're going to answer in the activity is, what can you conclude about two triangles if you know two pairs of corresponding angles are congruent? So only two pairs of corresponding angles are congruent. If you know that, what can you conclude about the two triangles? Okay, so here's a little activity. We'll try to do this as best we can on YouTube. Of course, in class, I can, walk around helping you and things of that nature, but we'll try to repeat the process here on YouTube as best we can. So step one is to draw a triangle EFG so that the measure of angle E equals 40 degrees and the measure of angle G equals 50 degrees. So at this point, you can pause the presentation and draw your triangle. But for the sake of this presentation, I'll continue at this point. So this is the triangle that I got. Triangle EFG with E measuring 40 degrees and G measuring 50 degrees. And then step two would be to draw a triangle RST so that the measure of angle R equals 40 degrees and the measure of angle T equals 50 degrees, but make RT longer than EG, okay? Draw it so that it's a longer line segment. So make line segment RT longer than line segment EG, so that triangle RST is not congruent to triangle EFG. And again, you can pause the presentation right now if you'd like and draw your triangle RST, but I will continue at this point. So here is my triangle RST with 40 degrees and 50 degrees. You can see that clearly the two triangles are not congruent. But what are the measures of angle F and angle S? So there's two possible ways, right, that you can do that. In class, I would have you discover this on your own. But for now, you can just use a protractor and measure the angle F and angle S using a protractor, or you can use the triangle sum theorem, right, and go 180 minus 40 minus 50. Either way, you should get that both angle F and angle S are 90 degrees. And then I'd like you to measure and record the side lengths of both triangles. So again, this is really a class activity, but what you should be discovering is that the corresponding angles are all congruent, right? 40, 50, 90 for RST and 40, 50, 90 for EFG. And the corresponding side lengths are not equal, but they should be proportional. So that leads to the angle-angle similarity postulate. So please write this down. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So in this case, we have angle K is congruent to angle Y. Angle J is congruent to angle X, and all we know are those two. So we can conclude that triangle JKL is similar to triangle XYZ. In other words, you don't need to know the measures of the sides or the third pair of angles. Okay? So let's bring home this concept by doing two problems and show that the triangles are similar, and then write a similarity statement. So here's the first problem. We have triangle FGH and triangle RQS, and we have that these three angles are congruent. Well, the only way that can possibly happen, right, we went over this in another chapter, in an earlier chapter, is if these are all 60 degrees. So we have 60, 60, 60, and this triangle is 60, 60, 60. So then we have that in each triangle, all three angles equal 60 degrees. So by the angle-angle similarity postulate, the triangles are similar. Okay? So that's how the concept will be used, how the postulate, the angle-angle similarity postulate will be used. And so the similarity statement is that triangle FGH is similar to triangle QRS. Okay? Second problem is regarding triangle CDF and triangle DEF. Okay? So we have triangle CDF right there, and then we have triangle DEF. And we need to show that these two triangles are similar and then write a similarity statement. So since the measure of angle CDF equals 58 degrees by the triangle sum theorem, right? So we have that this is 58 degrees, and the measure of angle DFE equals 90 degrees by the linear pair postulate, right? This is a straight line, right? CE is a straight line, so you have 180 minus 90 is 90. So DFE, angle DFE equals 90 degrees. Then the two triangles are similar, again, by the angle-angle similarity postulate. And my similarity statement is going to be triangle CDF is similar to triangle DEF. Okay, let's see how the angle-angle similarity postulate can be used to solve real-life problems. Let's say you want to measure the height of a flagpole, but you cannot climb the flagpole or otherwise measure the height of the flagpole directly. How can you use similar triangles to measure the height of the flagpole? Well, let's say the flagpole casts a shadow that is 50 feet long. You can measure the length of the shadow quite easily because it's on the ground, right? Now say that you have a friend who is 5 feet 4 inches tall. Stand by the flagpole at the same time that the flagpole is casting the 50-foot shadow. Now you can measure the length of your friend's shadow, and by using the angle-angle similarity postulate, you can calculate the height of the flagpole without having to climb the pole. And excuse the change in text there. I accidentally truncated my typing, and so I had to just add it this way. But anyway, how can you calculate the height of the flagpole without having to actually climb the pole? Okay, so remember that in lesson 4.6 you learned a way to use congruent triangles to find measurements indirectly. So another useful way to find measurements indirectly is by using similar triangles. So in this picture, these were congruent triangles. Okay, and you don't have to write any of this down. This is again from your 4.6 notes. But the 4.6 was regarding congruent triangles, and this is going to be similar triangles. Okay, so let's say you have the sun and you have your friend who's 5 feet 4 inches tall, casting a shadow that is 40 inches long. Well, at the same time of day that this is happening, that your 5 foot 4 inch friend is casting a 40-inch shadow, you have this flagpole, and it's casting a 50-foot shadow, and we can find out how tall the flagpole is without actually having to climb the flagpole. And of course, since your friend is standing out there casting a 40-inch shadow at the same time the flagpole is casting a 50-foot shadow, these two angles must be the same, right? The sun's rays hit the flagpole and your friend at the same angle. So we have that these two corresponding angles are congruent, and these two corresponding angles are congruent, right? They're both 90 degrees because you're standing, or your friend rather, is standing up straight and tall, and the flagpole is also perpendicular to the ground as well. So we have two pairs of congruent angles. So the triangles are similar by the angle-angle similarity postulate. So we can use a proportion to find the missing height, right? And I always find it useful, and we'll have some activities on this in the future, just creating these proportions by using little charts like this. I find it useful to create charts just to keep myself straight so that I don't make any mistakes. Okay, so everything in this column has to do with heights, and everything down here is going to be heights. Okay, and everything in this column is going to have to do with shadow lengths. Everything down here is going to have to do with shadow lengths. And everything in this row is going to be regarding the flagpole, and everything in this row is going to be regarding your friend. So this is just, like I said, a way to keep you straight. So what is the height of the flagpole? That's what we're trying to find out. It's x. And then what is the height of your friend, or how tall is your friend? And that's 5 feet 4 inches tall, which is 64 inches, right? Because there's 12 inches in a foot. 5 times 12 is 60, plus the 4 is 64 inches. And then going to this, what is the shadow length of the flagpole? That's 50 feet, right? It's given as 50 feet. And then what is the shadow length that your friend is casting? Okay, and that is 40 inches. So hope you're getting an understanding of how the angle-angle similarity postulate can be used. You can easily figure out how tall your friend is. You can just measure this distance on the ground. You can measure this distance on the ground. You don't have to actually climb the flagpole to find the height of the flagpole. Okay, so now we have this proportion set up. So we can just put it together mathematically like that. X over 64 is equal to 50 over 40, and then cross multiply and get 40x is equal to 64 times 50. And so x is equal to 64 times 50 divided by 40. And this is actually, let me do something here. This would actually be 64 inches, and that's going to be 50 feet divided by 40 inches. So the inches goes out with inches, and the only thing left is feet. So our answer is going to be in feet, which is 80 feet. So the flagpole is 80 feet tall. It's an 80-foot tall flagpole, and that's how you can use similar triangles and measure, the height of buildings or the height of, flagpoles, things like that. Much easier fashion to do it mathematically than having to, actually climb up there. So that's the end of the presentation. If you have any questions, please feel free to ask me, and it would be my pleasure to help you, to meet with you at any time, give you some extra private tutoring, anything you might need. So please just, tell me you're having some problems, and it would be my pleasure to help you. Okay, thank you. Bye-bye.